Welcome to the Access Web Express video equal Scallop, a closer look. Today I'm going to show a few ways to control and set up the equal Scallop toolpath. My name is Bob Delisle. I'm one of the application engineers here at Access. And without further ado, let's get going. Okay, I'm going to start with a very simple flat surface. I created a 4x6 rectangle and put a surface onto it. I'm going to go ahead and select my machine. I'm just going to select the mill default. And then from the 3D toolpath gallery, I'm going to select equal Scallop. The equal Scallop parameters box opens up. I have both machining geometry and avoidance geometry listed. I'm not going to use any avoidance geometry in this case. I'm just going to use machining geometry. I'm going to reset my wall and floor stock down here with reset stock values to 0. And I'm going to select my surface. I'm going to grab a tool. In this case, I'm going to use a 3/8 ball end mill. Speeds and feeds really aren't important, so I'm not going to go in there. And I'm going to leave everything else as the default values. I'm going to hit the green check mark. And there we go. The equal Scallop toolpath takes my step over and creates a very clean toolpath. There's a few things that I want to talk about right off the bat. If we look at the transitions in directions, they are sharp corners. Your machine probably doesn't like sharp corner or sharp direction changes. So I'm going to talk about changing that. So I'm going to go back into the parameters. And in my cut parameters, I have a tab called smoothing. And I'm just going to go ahead and check that, hit the green check mark, and recalculate the toolpath. And you can see those transitions now have radius movements instead of sharp corners. Much better condition. And if we look at this toolpath, right now all we're doing is looking at cutting motion. If I go to my View tab, I have the advanced display turned on, so I'm going to turn that off. And the toolpath, the cutting motion hasn't changed. You can see I have the lead-ins in between each pass, and that will show up on my part. And I don't like that in this case. So I have the ability to remove that. So I'm going to go back into parameters. In my cut parameters, in my cutting direction or cutting style, I have some options. And I'm going to select clockwise spiral. Hit the green check mark. And I'll recalculate that toolpath. And as you can see, all of those lead-ins are gone. This is a true 3D spiral. Much cleaner toolpath and a much better finish that this is going to produce. I'm going to go ahead and backplot this toolpath. And as I'm backplotting it, you'll notice it starts in the middle and works its way out. I can reverse that. So again, in the parameters, in my cut parameters box, expand inside out is currently checked. I'm going to go ahead and uncheck that. We'll green check mark that and recalculate. And when I backplot, you can see it starts from the outside. Now the toolpath itself, I cannot control the direction in which it cuts. But what I can do is create a curve or select a curve, piece of wireframe, solid edge, that will control the direction of cut. So what I've done is created some simple wireframe shapes. And I'm going to go back into my toolpath, into the parameters, into my toolpath control page, and down here to the right, you can see I have a curves box that I can select a curve. And I'm going to select this line. Green check mark that, green check mark the parameters box, and then recalculate the toolpath. And you'll see I get quite the different result. I'm going to turn my advanced display on because really all I'm concerned about is cutting motion. The reason I get this result is because my geometry, it's the surface, right? And the outside of that rectangle, and then this is my drive curve. And it calculates this toolpath based on the limits of my surface and my drive curve. So it tries to follow this drive curve, but it gets to a point because of the limits of my geometry, it won't allow it to continue this shape. Well, what if I wanted to continue that shape? Again, I can go into the parameters box. And on my toolpath control, you see I've got an area that says strategy, and currently closed offset is selected. And again, closed offset refers to my geometry and the limits of that geometry, and that's the extent to which it calculates the toolpath. I'm going to select trimmed offsets, hit the green check mark, and recalculate the toolpath, and you'll see I get a completely different result. This result takes into account my drive curve, uses that to create the toolpath, and expands it infinitely outward. And then it takes my geometry, the boundary of my geometry, and trims that toolpath. In this case, this is what I would want. So I'm going to do a couple other examples here. I'm going to use this rectangle that I've created here instead of this line. So I'm going to go into the parameters. I'm going to reselect that curve, in this case, that rectangle. And without changing anything else, recalculate the toolpath. And you can see this takes this rectangle and tries to expand it ever outward. And I get to these little areas right here. And the reason for this is because I still have true spiral on. And the spiral tries to use a true 3D spiral as it goes out. If I turn the advanced display off and rotate the geometry ever so slightly, you can see where the transition of that toolpath happened. Go back to a top view. Turn my advanced back on. If I didn't like that, what I can do is go back into the parameters, go back into my cut parameters, and switch this back to one way. And if you look at these areas out here, it looks like there isn't a toolpath. That's just graphics on my laptop. If I rotate this ever so slightly, you can see those come back. Much better toolpath. The issue, however, with this toolpath is I get my lead-ins. So this will show up on your part. So it really depends on what you're looking to get. I'm going to use these circles now just to show you the difference and how easy it is to control this toolpath. So if I just select one of these circles and go ahead and recalculate that toolpath, I get the result that you would expect. It expands from the circle ever outward, looks like a ripple in a pond, and then it's trimmed because of the geometry extents. It uses the boundary of the geometry and trims the toolpath. I'm going to go ahead and add this other circle. So we're going to say add. I'll add that circle. Say okay, okay, and recalculate. And I get something that looks like that. And if that's what you're looking for in this toolpath, the nice thing about the equal scallop toolpath is I can create these different patterns very simply just by selecting different geometry, different curves. And the last thing I'm going to do with this simple piece of geometry is to show you something that I thought looked pretty cool. And I'm just going to add this rectangle to the mix. I'm going to say okay, and I'm going to change it back to closed offsets. And we're going to go ahead and recalculate it. That's the result I get. And I thought this particular result looked good. It was a cool pattern. And the first thing that came to mind is tiles. If I was doing a backdrop in my kitchen, I thought that pattern on a tiles next to each other would look kind of cool. So I've really just scratched the surface in different ways to control the equal scallop toolpath. It probably took 5, maybe 15 minutes to come up with the curves to drive this toolpath. More than likely, the drive curves you're going to use are related to the geometry in some way, and it's going to control the toolpath and give you the finish, the desired finish that you're looking for. Let's take a look at part number 2. A little bit more complex part. I've got some cavities in this block that we're going to be machining, and I also have toolpaths that have already been calculated. We'll start from the bottom up. The bottom toolpath is essentially just machining geometry, avoidance geometry, a cutter, and a step over. And I'm going to shut the part off so we can see the toolpath a little bit better. And when we turn this toolpath on, you're going to see that the result that I get isn't exactly what I was hoping for. The result I get looks like this. And you can see I've got 3 distinct tool motions in these 2 pockets. Really not what I was looking for. So because of that, I don't just give up on the toolpath. I'm going to go and see if I can make some fine adjustments to that toolpath. So toolpath number 9, I'm going to take a look at the parameters. And the step over is the same, the geometry is the same, the transitions, the cutting style is the same. The only difference between the first toolpath and this toolpath is my strategy. With the part that we did before, trimmed offset seemed to work the best, to where it calculated the toolpath to infinity and then trimmed it off based on my geometry. Well, this time that didn't work so well. So I'm going to change it to closed offsets, recalculate the toolpath, and I get this result. This result is a much better result. I don't have the changes in motion of the tool. The tool follows essentially the same motion throughout. Now, when I get to the center, the transition between the 2 cavities, there's a couple little issues. I've got those transitional paths that it tries to maintain the spiral, but that's the area right there in the middle that I'm going to see if I can do anything with. So what I did for toolpath number 7 is I added not only a containment boundary, but I added curves to use as guides. So I created those 2 little circles. I didn't pay too much attention to how big they were, but I did make them the same. I selected those as drive curves, and I contained the toolpath using the solid edge. I'm going to go ahead and turn the part on here, and I use that solid edge as a containment boundary. I'm still using the avoidance geometry on that top face, and I'm still have the cavities selected and the radii at the top of those as machining geometry. But that's just something to try, just some R&D to see if it affects the toolpath, and in fact, it did. So that's the result I get, and it's better, I will admit. I'm still not crazy about the transition between the cavities. So what I decided to do was create another drive curve. So instead of using those circles as drive curves, I created this very short line, just a real small piece of wireframe. Again, it doesn't matter where it lives as long as it's inside. I tried to make it at the center between those 2 cavities, and I selected that. And at first glance, I like it. Everything looks good in the area. The reason I created it was because of that transition area, and I think that transition area looks better. But looking at the rest of the geometry, I'm not crazy about the way that cutter is going to drive from the top down the bottom up the other side. It's typically not a very good cut condition, especially on the side walls or the steeper portion of those cavities. I did create some stock models, and that's the stock model gives you a better idea of that motion of what I'm talking about on those sidewalls. Not real crazy about that, and that is the majority of this geometry. So I think it would be best to concentrate on those areas to make those areas correct and kind of deal with that transition area in between the cavities. So my next option that I tried, right? So there's the option using that small line as a drive curve, is toolpath number 3. And again, there's toolpath number 7. There's toolpath number 3. Very subtle differences, and the only difference between toolpath 7 and 3 is the fact that I use a containment boundary in toolpath number 7. I didn't for toolpath number 3. And looking at that, that's probably the best motion that I'm going to get out of the toolpath. So I'm using the trimmed offsets, not the closed offsets, because I am indeed using the drive curves. I'm not just using the geometry. So my cut parameters, I'm starting down at the bottom, expanding inside out. I am using a clockwise spiral. Again, these parameters haven't changed from toolpath to toolpath. So now that I've got the motion that I want to create, I'm going to go ahead and copy toolpath number 3 to toolpath number 1 and change my step over from 50 thousandths to 6 thousandths. And you can see the type of finish that I'm going to get in those cavities. A much cleaner, more precise finish. 5-10 minutes worth of messing around with the toolpath, changing a setting here and there, gave me the result I want. Thank you very much for taking the time to watch the video today. I hope you were able to find some things in the couple examples that we used today that you can use moving forward. Not all of your geometry will lend itself to this toolpath, but when you find the combination of the right toolpath and the right settings for the equal scallop toolpath, you'll find that it can be a very handy tool inside of your toolbox. Look for more videos coming soon, and please subscribe to our YouTube channel, which is the Access Web Express. And again, thank you for coming, and have a great day.